Good morning, students. Moving towards the computational insights of the linear programming problem, let us now take a linear programming problem which possesses an infeasible solution and try to prove the solution is infeasible via number 1 graphical method, number 2 simplex method. Now, take up a problem of linear programming that states that maximum of z equal to 4x1 plus 5x2 subjected to two inequalities, namely x1 plus x2 less than or equal to 1. Similarly, 2x1 plus 3x2 greater than or equal to 6. These are the two inequalities given. As usual, non-negative restrictions x1 comma x2 greater than or equal to 0 given, right. Now, let us go for graphical method of proving this solution to be infeasible. Now, let us have this as x1 axis and this as x2 axis, right. For x1 plus x2 less than or equal to 1, if you put x2 equal to 0, x1 is 1, so 1 is here. If you put x1 0, x2 1, so 1 is here. So, line joining these two are given by this. So, you will have 1 comma 0 being named as B and one more point 0 comma 1 being named as A. These are all the 2 points on the axis along through which this line passes through, and the corresponding inequality is less than or equal to. So, I have to draw lines, arrows facing towards the origin. So, now the feasible region corresponding to this inequality can be stated as the collection of points that sit below this line 1, and this line 1 is given by x1 plus x2 less than or equal to 1. Similarly, for this next line, if you put x1 0, x2 is 3, sorry, x2 is 2, 6 divided by 3 is 2, 1 2 will be here, and if you put x2 0, 2x1 equal to 6 and x1 equal to 3, 1 2 3 will be somewhere here, right. So, this is 3 comma 0, this is 0 comma 2, call this as C and this point as D, right. Now, line joining these two can be drawn like this, okay. Now, x1 comma x2 greater than or equal to 0 means we are very well in the first quadrant. x1 greater than or equal to 0 means points above the x1 axis, x2 greater than or equal to 0 means points to the right of x2 axis. So, already we are in the first quadrant. Now, 2x1 plus 3x2 greater than or equal to 6 means arrows to be drawn facing the facing above from away from the origin. Now, these are all the arrows. Now, usually when we keep the feasible region will be bounded by lines. Here, though there are two lines representing these two inequalities, the arrows, one facing the origin and the other facing away from the origin, make clear demarcation between these two regions. That means there is no common region corresponding to both the inequalities. If you have the 2x1 plus 3x2 is greater than or equal to 6, that means points above this line 2, points above this line 2. If you take this inequality 1 x1 plus x2 less than or equal to 1 means you will have collection of points that sit below this first inequality, that is facing the origin. So, there is no common point which can obey both the inequalities, and hence a feasible region cannot be found. So, what should we write now? That is from the above figure, we cannot find feasible region obeying both 1 and 2, inequalities 1 and 2. Therefore, solution is infeasible. That is what now I say, solution is infeasible. Now let us find the infeasibility of this linear programming problem through simplex method. How? Let us first have the slack and surplus variable what we need to introduce with respect to the inequalities. Say first inequality is x1 plus x2 less than or equal to means, that means I need to add one slack variable s1 to be made this to be equal to 1. For the second one I need to have 2x1 plus 3x2, then one surplus variable minus s1, one artificial variable a1 to be made equal to 6. Now what do I do is I draw simplex table to find out the solution now. How? As usual I will have basis first, then cost basis second, then basic variables x1 and x2 third, then first inequality slack variable s1, then second inequality artificial variable a1. Instead of fixing surplus variable, why I am putting artificial variable? Then only I will have unit matrix under these two variables, that is why. So one more surplus variable s1, all those things now are plotted. After that as usual I will have P naught, then ratio column theta j. So all operations in between CB and P naught. So I block this. Now let me fix the Cj. Cj are the cost coefficients available in objective function. What are the cost coefficients available in objective function? 4, then once again 5, then I will have S1 coefficient in cost is 0. A1 I have to associate minus m, a very big quantity with a negative sign I have to associate for artificial variable. Then S1 0, P naught dash. Then I have to fill up this first table, that is first inequality I will have 1 here, 1 here, S1 coefficient is 1, no A1 0, no S2 0. So this is S2, this is also S2 because we have already got S1 there. So what is P naught? P naught is 1. For the second inequality I will have 2 first, then 3 second, then S2 coefficient minus 1, A1 coefficient 1, S1 coefficient 0, P naught is 6. So I block this with the help of 2 lines in order to compute Zj minus Ej. Now what is unit matrix where that is distributed? S1 A1. So for S1 you have to write S as S1. A1 will have 1 here and again you have to write A1 here. S1 coefficient is already 0. S1 coefficient is already 0. A1 coefficient is already minus m. So I need to compute Zj minus Ej. As I told you already 0 into 1 0, then you have minus m into 2 minus 2m minus 4, minus 2m minus 4. Then for this you will have 0 minus 3m minus 5, minus 3m minus 5, 0 0 0, then 0 minus m minus m 0. Then you have positive, so no need to write. Then no, don't write this. So what is the pivot row now? What is the most negative in Zj minus Ej? This is the most negative. So this is the pivot column, and P naught column is to be divided by pivot column. 1 divided by 1 1, 6 divided by 3 is 2. Among this 1 is least, so this will be our pivot row, and the intersection of pivot row and the pivot column is the pivot element. Now I write S1 leaves and x2 enters. S1 leaves and x2 enters. Now I write x2 here, whose cost in the objective function is that 5. Now I have to divide the old pivot row by pivot element. Pivot element is already 1, so I can divide directly. 1, 1, 1 by 1, once again 1, 1, 0 by 1, 0, 0 by 1, 0, 1 by 1, 1. But for S1 we will have SA1 there. So, for A1 the cost is minus m. So, what do I do is that I have to fill this. How? To make this entry 0, I have to multiply the new pivot row by 3 and subtracting from the old pivot row. So, I will get 0 here. 1 into 3, 3, 1 minus 3 is minus 2. To make this 3 entry to be 0, I have to multiply this by 3 and subtract from that, right. So, 1 into 3, 3, 2 minus of 3 minus 1, 3 into 3 0, 3 then we will have minus 3, then if you multiply by 0, 3 1, then minus 1, 3 3, right. So, I have done this A1 row. Now, what I have to do? I have to compute Zj minus Cj. You will have positive m plus 5 positive, then m minus 4. So, answer is positive. Here 0, 5, 0, then positive plus 5 positive, positive. Now, minus m minus of minus m 0, then plus m 0 positive again. That. So, what do I have? I have all Zj minus Cj positive, where artificial variable appears in the basis column. So, in artificial variable technique, the optimum table should not have artificial variable in basis column. If it exists in the basis column, then the solution is infeasible, right. That means what? You will have solution as 5 minus 3m. So, m is very large and artificial variable does not leave this basis column even in the optimum table. How to realize the optimum table? All Zj minus Cj will be positive. Since all Zj minus Cj positive and artificial variable does not leave the basis column, the solution here turns to be an infeasible solution. Okay. So, we have now proved the infeasibility in the linear programming through two methods. One is the graphical method that looks aside, and one more is simplex method. The simplex method we have introduced both artificial surplus and slack. All those less than or equal to symbols will have slack variables to be introduced at the left, and all those greater than or equal to inequalities we will have an artificial variable as well as slack variable. That slack surplus variable is termed as minus S2, artificial variable is termed as A1, and the equal to symbol stands for equating these LHS and both sides and RHS with the help of artificial and surplus variables. Okay. Now, let us move to next problem.